My name is Sean Pierce, and this is Abusing Native Shims for Post-Exploitation. That's what it says. Track 101. Good morning. There's more people here than I thought there would be. I'm going to assume everyone is hungover. So, let's just get the show on the road. About me, my name is Sean Pierce. I have a CISSP and a few other certs. It's my Twitter handle. If you want to email me about any of this stuff, sdb@securesean.com. GitHub and sdb.tools are sites that I can control, or that GitHub directory. There we go. Just as a disclaimer, I'm not a pen tester, I'm not a developer, and I'm not an iSight representative. They are my employers. And then you might think, oh, why are you using their slides? It's because they look really nice. And to that point, I just want to say that I love who I work for, and there's just a bunch of great people there and really smart, and they're just fantastic, and I just cannot say enough good things about them, and they do threat intelligence, and if you want to know more about them, that's their website. So why am I here? Well, when I was 21, my dad took me to Las Vegas, and we were sitting down the Rio buffet, and he was like, what do you want to do today? And I saw someone walk by with a black hat bag. And I was just like, no way. And so I tracked him down, and I was like, oh, is this going on right now? And he's like, no, but DEF CON is. So I found it in Riviera. I snuck in and bought a T-shirt. And I had a great time, met some really cool people, and it really encouraged me to get into this field a lot more. And my dad passed away a few years ago, and I think he'd be really proud that I was giving this talk here today with y'all, and he really is the reason why I'm here. So, getting on to the talk. So, a bit of history behind application compatibility. It's kind of funny, and it is the reason why I think Microsoft has such a dominant place in the market, because they go to so much effort to keep with application compatibility, like an enormous amount of effort that you cannot even really imagine. And like just as a simple case study, the original Sim City that ran on Windows 3.1 or DOS 3.1, whatever, had a free after use vulnerability. It's a free after use bug. So it would free some memory, it would call the free function and say, I'm done with this memory, and still continue to use it. And that's terrible. But lucky for it, the old operating system didn't really use a whole lot of memory. It didn't really have a whole lot of concurrent processes running, and it didn't really take it back all that much. And then in the new operating system, Windows 95, the memory manager was way more efficient and had processes that it would actually want memory all the time. And so this program would crash quite frequently. And of course, if you're a user and you install your old favorite game on a new operating system with a nice new computer and it keeps crashing all the time, you're going to blame the operating system. And Microsoft really couldn't have this. And even like one of the heads of the Windows dev team, he drove down with his pickup truck to a local egghead store when there were still egghead stores, and he filled up his pickup truck with every game he could buy off the shelf from the store, and he drove it back to Redmond and said to his developers, everyone take at least 3 games, and it has to work on Windows 95. It just has to. And so they would hard code things into the operating system to watch for certain crappy code that was written by random people all over the world, and they would account for that in the operating system, which is kind of terrible, but it was what they needed to do to maintain such application compatibility. And there are other case stories, and I encourage you to read The Old New Thing. One of the Windows developers and testers, he had this blog called The Old New Thing, and he put it into a book. And some of the stories are pretty funny. Like, he had one where the graphics card manufacturer wrote this driver, and in the driver specifications, you have to implement this function that basically says, takes in one parameter, and it says, do you support this? Return Boolean true or false. And this graphics card manufacturer simply returned true for everything, which is terrible because that's how the operating system determined if it should do something in hardware or software. And so Microsoft called them up and was just like, hey, WTF. And they were just like, we don't care. Honestly, we don't care. And even if we did, we'd have no way of pushing out a patch. And even if we wanted to do that, that card is old and we don't even support that anymore, and we don't even have the source code for it anymore, which is apparently a really common problem. And so Microsoft built their own database of what graphics cards supported what, and they hooked that function, and then they just did it all themselves. So Microsoft goes to great lengths to make sure that this stuff still works. And it's not just for third-party bad code or just dumb programmers. It's also for OS bugs, because certain programmers leaned on certain features, or lack thereof, in the operating system, such as this case study of a synchronous buffer commit. Basically, when you call a write function and you think you're writing some data to the disk, you're actually just putting it into the buffer, and the operating system will write things efficiently to the hard drive in batches or whatever else. But if you have like a database program, that's not so good, because you need to guarantee that your file, that your database is in a certain state. Now, Windows had this function where it would basically say, write everything to disk, flush the buffer, synchronous buffer commit to the disk. Great. So you can guarantee that it worked. And developers love this because it was really efficient. They saw that there was almost no performance impact. And then they moved to like a newer version of the operating system, Windows 95, and they noticed their database program was going really, really slow. And it turned out Microsoft never actually implemented that function. It was a NOP. It didn't actually do anything. So when they thought they were like flushing something to disk, it wasn't at all, which is terrible. So what was Microsoft to do with these programs that are now running super slow? They NOP out the function again. So, which is hilarious. This lying, where the operating system pretends or lies about something, frequently happens between versions of Windows. Like Windows 7, like that's the major version, is 7. But there are so many programs that had bugs in how it determined what version something was. They just called it Windows 6.1. Like that's the function call, that's what it returns, is Windows 6.1 instead of 7. Because so many applications would run on Vista just fine, but fail to run on Windows 7. So they do crazy things like that, and they also have a lot of lying when it comes to 64-bit or 32-bit apps running in 64-bit machines. And I'll have some examples here in a bit. So a while ago, Microsoft tried to stop hard coding values into the operating system, and they started to bundle a bunch of stuff together. So there's a few basic vocabulary words. There's a fix, there's a mode, and there's a shim. So a fix is one of these little things. This is just if you right-click on a program and then go to Properties and go to the Compatibility tab. Here you can say, run as administrator, or have a certain display setting like that, and that's a fix. It's a single thing that does one little thing. A mode is a bunch of fixes bundled together. So if you say compatibility mode right here, then you say, I want Windows XP, SP3, or this or that, and you get a whole bunch of fixes that are already put together. And these configurations are bundled together in what they call a Shim Database File, or an SDB file. So what actually happens when a process is being shimmed? Well, some parent process will call a function like create process, or shell execute, or something like that. And when it gets down into lower level API calls, the operating system, NTDLL, checks the registry to see if this child process should be shimmed. And then it sets an undocumented environment variable called appcompat, or underscore appcompat, I do believe, maybe one underscore. And it'll specify what it needs to do. And then the child process does a similar kind of checking to make sure it should be shimmed as well. So it typically works in that a table, a data structure in memory called the import address table, holds all the addresses for the operating system function calls that that program is going to use. And this is cool because most hooking, including this rootkit framework, compatibility framework, will use that table to hook in whatever it wants to manipulate. So when I say shim, I'm usually talking about the code that sits in between the import address table and the rest of the Windows API. And they made some great hooking libraries, and they told no one about it. Like if you tried to dynamically load something, like with load library, it hooks that too. If you try to get the export address table for one of the DLLs, it'll get that too. So they do this stuff pretty well. So the official uses for shims are not just for third parties, but a good use example is a fix-it patch. So if you are seeing exploit against your enterprise and it's a 0 day and you tell Microsoft and they're like, okay, we'll patch it come Tuesday, patch Tuesday in a month, and you're just like, I can't wait for that, they'll give you a fix-it patch. And if you crack that open, you'll see that's actually just a Shim Database file, an SDB file with certain configurations. And usually that has some kind of patching information. And a lot of times it's not like a super elegant fix, but it'll, like, worst comes to worst, it'll cause a memory leak or it'll crash the process before it gets exploited. So it's a better solution than getting exploited. EMIT, the Enhanced Mitigation Experience Toolkit, uses shimming as well to get a process and either like up its security by like saying you must enforce ALSR, you must enforce DEP, and other stuff like that. And it's really quite effective. So I want to introduce to you the tool that Microsoft released that lets us make our own shims. And it's called the Application Compatibility Administrator. And I want to show you a cool undocumented trick. And the text, like I said, is a little small. You need to be administrator to run this. Well, you need to be administrator to install the shim, and I'll tell you why in a minute. So here, I created a fix. I specified putty.exe is the program that I wanted to shim, and I said, here's the file on disk. I'll tell you why in a minute it wanted the file so badly. Now, you'll see here that there's a bunch of fixes that Microsoft has already made, or I'm sorry, modes. And they provide all this internally, and that's really cool of them. But they provide like 300 some odd fixes. Some of them like API tracer, API logger, read BIOS, reroute registry keys, reroute file paths, fun stuff. Now, if you go to where that program is and you open up a command line and then you run the app compat or the application compatibility administrator from the command line with the option of /x, everything will look normal and you go through the same sort of thing. I'll specify that Putty should be the program, my target program. Now you'll notice that instead of like the 300 and some odd fixes we had, we now have 808. A lot of them are very special. They're very specific to a program. So you see like Adobe Acrobat 5 or Norton Antivirus or something like that. And that's fun, it's cool to see how Microsoft was manipulating those particular processes. Now, I just specified one of my favorite fixes called inject DLL. And as you can imagine, it allows us to inject any arbitrary DLL, even over a UNC path, into any process we choose, and it runs with that process's rights. So here I'm just specifying a DLL that I stored in the root directory. Now, earlier I chose Putty. I had to browse to Putty and say, I want this executable. And this is the reason why, because it went and analyzed that file and said, here's a checksum, here's a bunch of stuff I can trigger off of, compile time and all that. And I can use that to trigger and execute my shim. But I removed all those and said I just wanted to trigger off the name, putty.exe. I'll let this video run. So I have to save a Shim database file beforehand. I just specified the file name, and I'm saving it to disk. I'm going to use a program called SDB-inst, an installer for SDB files that's found on every Windows computer out there. I'm installing it on the command line here, SDB-inst. You should pay attention to this tool because we'll talk about it later. Oh, God.
No, we won't.
All right, come on. And I'll say installed successfully.
Oh, really? Hang on a second. My cock is going crazy.
And then it's installed. So now every time I execute Putty.
Okay.
Wait.
All right, go ahead. We're going to make a point.
There's my DLL. Quickly.
Are we? No, what do we? Jesus, I've never met a more Grabby speaker in my life.
No, it's just, I always run out of time in all my practice talks.
Oh, I'm sorry. All right, well then we'll get this over quickly. We also have Mike on stage. Mike is a new attendee. He's representing all you new attendees. So, how's he doing? I have one question for the crowd. Fuck are you doing here at 10 a.m. on Sunday? You must be some kind of god or something. Anyway, there you go. First time attendee, DEF CON. Cheers. Thank you for coming. Sorry, we get out of your head.
Anyways.
Let's talk about Putty now.
Great Putty.
Also, I really like more of a conversation. So if someone has more of a question, feel free to yell out. But I do have to roll pretty fast on this. Okay, everyone good on that? Just made a shim and installed it with Microsoft's tool. Now this is the public version of the tool. They have a private version which shows them more information and gives them a bit more capability on a lot of things. And I'll show you some of those things in a minute. But one of the major ones is hot patching. This public tool has no awareness of hot patching, but in Shim Database Files you can specify that something be hot patched, and that is crazy powerful. So I said you need to be administrator, and you really only need to be administrator to write to 2 registry keys, and that's all it takes to install a shim, and that's all SDB-inst did. Well, it did a little more. So basically it copied my SDB file that was on the desktop and then dropped it into a Windows folder so it can't be messed with, and made 2 registry entries. The first one specifies that there is a program, putty.exe, that does need to be shimmed, and then the second one right under it, installed SDB, this is a GUID that points to this one, and it specifies exactly the path on disk of my Shim database file, the SDB file. And I've played with this, and it's funny because you can actually specify, go in there, and change that to a UNC path, so you can actually have your Shim database loaded over the network instead, which is hilarious. So those are the registry keys that I was referring to. So they're current Hive key local machine. That's why you need admin privileges. But if you boot it from a live disk and you're able to edit the registry, you don't need to be admin. And those are the default file locations that it'll drop the copied SDB file into. Now if you use SDB-inst, the standard installer that's found on all the Windows machines, and you install something, it'll add that fix to the add remove programs. It'll add that shim to the add remove programs menu, and you can just click it and say uninstall and it'll pop it out. Bad guys I've seen have used this. They'll use SDB-inst and they'll install their shim, do their thing, and then immediately uninstall it because they don't want it showing up here. And that's really weird to me because all it does is add those registry keys. That's all you need. So if they just added those registry keys, they wouldn't have this show up. But I've never seen any bad guy manually install something to the registry, or manually install a shim. So there's a simple YAR rule that I put up there, and it keys off the magic value. So what can we do with this more maliciously? We can do targeted persistence. Obviously, if Putty is run every single time, there is some stuff I can grab from it, or whatever. I'll show a demo in a second. But we already kind of had that. There is this registry key that Malware has used. It's been around for a while. And if you have a program name in it, and then you have the string debugger, then it will execute your debugger instead of this program. So we have a similar type of persistence mechanism, but shims are way more powerful. We can do some API logging. We can terminate any application we want. There's a terminate exe fix. I don't know why that's a fix, but there's just crazy things you can do with it. You can, since you're already in the process space, you can capture all the credentials that are going through. You can redirect application logs. You can snoop/redirect network traffic. You can Trojanize any application like we saw with putty.exe. And cyber espionage groups have used this before. Like there was one group that was very interested in SCADA systems, and so when they compromise a machine, they drop a Shim database file, which would just key off that SCADA software running. So if the software never ran, they wouldn't care and they wouldn't get a call back. But if it did run, it would grab this information and execute their malicious code and send back some config stuff. So we can also force vulnerable DLL loading. So I can specify that an old DLL should be loaded instead of the nice new one. So I can reintroduce a 10-year-old vulnerability into a system if I ever get kicked out. I can subvert system integrity, and I'm going to show an example of that. I could have done in the past UAC bypassing, but Microsoft just patched that. I was just like, just right before my talk. So, and since I'm a malware guy, I'm really into malware obfuscation. I'll let you read that for a second. So in Windows Vista, if y'all will remember, there was the UAC prompt popping up left and right all over the time because processes needed to elevate their privileges to do something. Legitimate things like get direct access to the hard drive or right to the registry, or even sound volume is the one that's usually targeted. And people didn't like that. So Microsoft quietly added this little feature and didn't document it anywhere. And the manifest file, the manifest part of the binary, called auto elevate, and it would set that equal to true. And if that was correct, then that program, when it launched, would automatically elevate to system level authority, and which is hilarious. They didn't think it was that big a deal because you have to be signed by Microsoft in order for this property to work. But with shims, there's a cool little fix called redirect exe that says, oh, you see that program running? No, run this one instead. You know, just because. And run it with the same privileges. So the common tactic would be to install a shim, and you have your malware on disk, or UNC path, and you say, okay, I want to run sound volume. But wait a second, redirect exe, run this thing instead, and my malware now has the system level privileges that sound volume did. So that's fun. And here's a little sample of the Drydex malware using it. It would run sdb-inst, again making this add remove programs entry and whatever else, and it would just use this redirect exe fix for its malware because it wanted to install as higher privileges. A number of malware families have used this. Much more recently, in the past year, it's become more widely used. But I think after the Microsoft fix, it won't be used as much. However, the Microsoft patch was an optional patch and didn't install by default, just FYI, depending on your group policy settings. So BlackEnergy, rootkit, roaming tiger, search protect. I actually got infected with it when I began doing my research. It's just a potentially unwanted program. It's not that big a deal. Uktar A, or update spelled weird, Drydex, and there's a few other malware families, but these are like the big ones. So BlackEnergy, particularly the second variation, is an interesting piece of malware because it's been around for a while. It was originally used for cybercrime, and then it was picked up for use by cyber espionage and got way more sophisticated with 64-bit plugins, rootkits, and all this other fun stuff. And it used shimming for a UAC bypass, and it was the first malware family to do so, at least that I know of. And they also did something else slightly interesting. They used another fix called disable NX show UI, which was it disables the NX bit so you can execute stuff on the stack. So that was funny. The second espionage group to do something interesting with it was called Roaming Tiger. It was outed by ESETS. Anton, I don't want to butcher his last name. This group was outed last year as well by Eyesight, by my company. They called it Sandworm. They attributed it to the Sandworm team. This group was outed by ESET at Zero Nights last year as well. And here we can see, well, it may not be very easy to see, but we're using John Erickson, his SDB Explorer, to analyze this SDB file that they would drop. And they would basically say, I don't want any of the Microsoft predefined fixes, although there are plenty. I want my own fix, which you can do. And they said their fix applies to explore.exe. And all you need to do to make a custom fix is to make a DLL that exports two functions, and then you need a shim that says use this DLL. That's where the fix is. Pretty simple to do. So I'd like to show some examples of how a pen tester might use this stuff or how malware might use this in the future. There's anti-analysis examples that I'll get to in a bit. But I really like the idea of old to new, where you take a crappy old piece of malware with some hard-coded IP address or a registry key value or a path name or whatever, and when it runs on a system that you've compromised, you can specify, hey, change this at runtime. This IP address is actually this IP address. This registry value is this. This is actually exfilling to this location. So if an incident responder ever came across some computer, eventually you probably would, and finds that this malware is running, and you can make it some simple thing, and he dumps it, or he gets it off a disk, and he runs it in a sandbox, and he says, oh, it's just doing something really simple. It's beaconing out to this IP address. It's doing this, and that IP address has been dead. I'll search my enterprise for that IP address or domain name or whatever. I don't see it. Okay, we're good. That was hard-coded. No way to change it. Little does he know that it was changing dynamically at runtime, and incident responders for y'all out there should be aware that SDB files can modify things like that at runtime. Putty.exe I showed earlier with inject DLL fix. We can, where's my mouse? There it is. We can inject an arbitrary DLL. And there's a cool little program out there called Putty Writer by a guy named Adrian Fortuna. I'm sorry, Adrian, if I just butchered that. But it's cool in that it's a DLL that when injected into Putty will hook the basically input and output networking and will use a connect back to send you that information. So all you have to do, I just ran Putty on the left to show you that it is Putty. On the right, I've set up a Linux machine, and I've started a Netcat listener. And here I'll go through the same sort of deal where I make a fix and apply it to Putty for an inject DLL, and I specify Putty Writer. And Putty Writer will be injected from then on, no matter where you execute Putty from, as long as you're executing it on this machine, it will inject Putty Writer. It will connect back to my shell and show me everything that user is doing, which is awesome. And you can also configure Putty Writer to execute a command upon connection. So, if I were doing malicious things, I would just specify the command of, put this key into your authorized key files under the .ssh folder so I can now get in, or drop some connect back thing. There I'm specifying I don't want any of those things in case Putty came out with a new version. Although I guess they could change those send and receive function locations. So I'm going to fast forward it a bit because I don't have a whole lot of time. So there I am installing the shim from the command line, then deleting the file. Now here, I'm running Putty, and Putty Writer was automatically injected and made a connect back to my netcat listener on the right. And here you can see I am legitimately just using Putty to log in, and I can see all the keystrokes that are coming across, including the username and password, which will happen in just like 2 seconds because the SSH service was being super slow. And there you have it. So I can watch everything they are doing. I can inject a command in there. Fun stuff. Thank you. The second example I'm going to show you here is where I'm going to use the correct file path fix to redirect a path. Now, over on the right, there's a network share that I've opened up. It's like a machine called controller/catch is the share name. So here I'm making a shim specifying Firefox. I highly encourage all of you to check this out and look at every single one of these fixes, documented and otherwise, because there is a lot of fun to be had with these things. So normally with the correct file path fix, let's see if I can pause it. With the correct file path fix, it would fix some program that was hard-coded to C:/documents and settings to C:/users. And that was for like from Windows XP to Windows 7, because a lot of programs apparently made that mistake. And that's terrible, but they did that. They had lots and lots of path redirects for that kind of thing. And with that / or -b parameter, I'm saying don't do that. Don't do anything except for what I'm specifying right here, right now. And I do that right here. I found the Firefox profile, and then I give it a semicolon, and then give it the new path, which is / controller/catch. I remove all those parameters, all the filters that it could trigger off of. I'm going to fast forward this a little bit. I'm saving the file and installing it. Deleting that, the original SDB file. And then I'm executing Firefox, and here over on the right, it's redirecting all of its stuff over across to my network share, which is awesome. And there's the key3.db, which is where Firefox stores its password for that user. And there was no prompting from Mozilla, from Firefox, that the profile was changed or corrupted or anything, because it is being lied to by the operating system, which is hilarious. Another example, I mentioned subverting system integrity. That's kind of a big thing, for me at least, because I really prefer stealth and misdirection when it comes to war games, red teaming, all that fun stuff. And here, I'm demonstrating Autoruns, awesome, fantastic tool by Mark Ruskanovich, sysinternals, where it'll show you tons and tons of places where malware will really enjoy planting some code, because that's how it can get automatically executed when either a user logs in or when the machine boots up. I have several versions. Sorry, I'm going to rewind this a bit because I just downloaded and compiled Dexter, which is POS malware, and it's right there on the desktop, pos.exe, and I executed it, and it deleted itself. And I'm showing in this little video that I'll post on YouTube. I'll post all my stuff online eventually. And we can see with Autoruns, it's detecting that registry key has something really suspicious in it. And you can even right-click and go jump to value, and it will pull up regedit and show the exact registry key that it found that was so weird. So here I've made a shim, which is awesome, if I don't say so myself. And here, I'm redirecting the file paths, the registry keys, so that when it looks for that particular registry key, which is a particularly common one, which is the current version Microsoft Windows NT Run registry key, it redirects it to an empty registry key. So Autoruns, all these versions will not detect my malware anymore. Furthermore, I chose some other tools in there, like process explorer, proc dump, and I just added the terminate exe fix. So as soon as someone tries to execute any of those, they'll just fail. No way around that. Well, I say that you can easily just change the name of the process or change the name of the file and it won't be shimmed anymore. So that's hilarious. I can shim Autoruns, and even better, I've also added a shim for regedit. So the registry editor built into Microsoft will not detect my malware anymore. It will not see that malware key. Now, the latest version of Autoruns does something a little different, and so my default registry redirect shim doesn't really work on it. So it'll show up for the latest version, but none of the prior versions. So here, let me back up just a little bit. So for here, it showed up in the latest version, 13.4, and I said go to this registry key, and it's not there for regedit, which is hilarious. Okay, so moving on to the malware, which is my favorite thing because I really like malware. I broke it down to 3 categories. Benign executables, which we saw like Putty, where we can use a lot of fixes to make it malicious, like inject DLL or load library redirect, which is an awesome fix as well. And we can also do hot patching, where we could just hot patch in, just overwrite the OEP, and we can the original entry point for the executable, for those of you who don't know, or we could make our own ROP chain and use native code there to build out some malicious stuff. That's a little tedious. So the next category is, I would say, dependently malicious software or dependently malicious executable. And there can be some kind of kill switch in your program, in your malware, that without a shim installed on the system, it wouldn't be able to get around. Like there's an ignore exception fix. Or you can hot patch, all the jump instructions of the program and redirect the program flow at runtime to actually do your malicious deeds. Tons and tons of ways to do this. There is just an infinite number of ways you can make something bad or from bad to worse. And the last category was an obfuscated executable, where it is clearly malicious, but it'll just fail to do anything without the shim. So an example of the dependently malicious software would be something like this, where I have some shell code up there that I want to execute, and I use just MSF Venom to pull that out. And I'm sorry for those of you who can't see, I just got some Metasploit shellcode, and here I have some assembly that was label, jump to label, and that produces the EBFE instruction, which is an infinite loop. It just jumps to itself over and over again. So if you execute this program, it'll just stop right there. It'll just jump to itself over and over and over again. No way around that. So there's a shim here that I made with SDB Explorer that'll create a patch that just knocks out that EBFE instruction. So when this malware is running on the intended victim system, it will be malicious. It will actually call the shellcode. If not, the IR guy who dropped it in a sandbox will think that nothing is happening. And this is how I make and install that SDB file. So I use John Erickson's SDB explorer.exe/c and have that config file. And then that's the output of the program. Just specify, like output.sdb, and then I install it with SDB inst. You can also use John Erickson's SDB Explorer to install an SDB file stealthily by just adding the registry keys and not using SDB inst. So just FYI. Here's something more obfuscated. I have don't try to actually mess with this code because I just shortened it to make it easier to read. I have some shell code up there, some malicious shell code, and then right below it I have the shell code key. I made it the same length. And then I do some simple XOR obfuscation where for byte, key to shell code, it does an XOR and then tries to execute the result. And you might be thinking, okay, why not use a single byte key or multi-byte key or something like that? Well, this is because I can make a shim that patches over this key with a value that I choose. So I can decrypt this to literally anything I want. So by default, I can make it benign, and then maliciously, with the right patch, I can say I want these bytes now to be some Metasploit code, or I now want these bytes to be something else. So I can do that quite easily. And I think that's quite exciting because when you have this kind of Packer type stub in the shim, you don't have your malicious payload on file or in the malware, and you don't have it in the shim, but it will only be produced dynamically on the target system if you so choose. So for those of you who just want straight up persistence, here's the config for patching explorer.exe for Windows 7 64-bit, Windows 7 x86, and Windows 8. And so, sorry, I have to run through this real fast. Current prevention from this, because I don't like just releasing malicious tools. I made a number of good tools, but what can defenders do? Well, you can disable shimming through group policy, but that's not recommended because Windows uses this stuff internally. Like I believe IE, when you go into compatibility mode, that's actually using a shim. If there's a program named install.exe, it's automatically elevated through shimming. This is kind of important. If you have install.exe, it's automatically elevated in Windows. You can remove the shim engine, the thing that's actually doing the patching. That's not recommended either because, like I said, lots of other things use it, like emit. You can remove the SDB installer. That's a good start, unless you are applying fix-it patches to things. But you can bad guys can just use the manual entry method, the manual install method. And you can always just allow no administrative access to that box, but that's probably never going to happen. So the current tools out there, I've already talked about most of them. The public application compatibility toolkit and the manager, and the installer SDB-ins is on every Windows computer. SDB Explorer by Don Erickson will make shims and explore them, show you the database values and all the cool undocumented features in there. Shims.exe was made by a guy, I think his name is like David Tometz or something like that. And I told him I was giving this talk, and he was like, oh, that's cool, that's awesome. I was just like, hey, can I demo you your tool? He's just like, yeah, sure, go for it. I was like, yeah, can you send me like a trial version? He's like, no, you have to pay for it. I was just like, yeah, or you can just let me demo it, or screenshots. He's like, no, you're gonna have to pay for that. Like, whatever. There's a Kim cache phrase parser, made by Mandiant. Since shims are checked all the time because processes begin execution all the time, this is a great, they had to cache that information, and that's a great place for forensic value that a program was executed. So that explores some of that. But none of these programs and nothing out there helps defend or prevent malicious shims. So I made a number of tools, and I broke them into 3 categories. One is for detection, where you can scan a file for you can scan something so you can determine if it will be shimmed or not. It'll just tell you, yes, this would have been shimmed, and it'll tell you the thing that would have been applied to it, the fixes that would have been applied to it. There's a shim process scanner, which will scan every process in the OS. I've only tried it for Windows 7 64-bit, but it seems to work. And it does that through checking the DLLs that are loaded into the process to see if any of those are the shimming DLLs or app help DLLs. And it checks the registry, and it checks the PEB flags, because there are undocumented flags in the process environmental block structure that says whether something is being shimmed. And then I made just a really basic script to check for, to see if the DLLs are in any of the process spaces. And ShimGuard, I originally made this for the purpose of preventing shim from being installed, but that was actually pretty hard to do because that I would have to mess with the permissions, and then when something tried to install to it and failed, it would notify me, and that got a little too complicated. And then I just made a PowerShell script to alert as well. And then I made 2 plugins for the response side of things, one's for volatility and one's for Autopsy. Autopsy is an open source graphical forensic front end. And it's really cool that you can load a disk image or whatever else, and you can search for things on it, and I search for SDB files. And in the future, I'll start doing more stuff with it. And I whitelisted a bunch of hashes for known good SDB files. And Volatility is the open source live memory forensics framework, and I made a plugin for that to search for SDB files. So just to wrap it up, I'd like to have these quotes up there from Microsoft. I give them a lot of crap, but they've done an enormous amount of work, and I appreciate them a lot. But I love how the quotes say, no shim is available to bypass, the Windows 7 user account control, except for the redirect exe or the load library redirect. It says, no harmful code can be injected into the process, except for the inject DLL fix or custom fixes, and it's you're not opening any additional security vulnerabilities. You cannot use shims to bypass security mechanisms in Windows, except for the disable advanced RPC client hardening fix, or the disable Windows Defender fix, or the disable ALSR fix, or the disable SEH fix, or disable the NX bit fix. There's a few others out there that are pretty hilarious. I just want to note some prior work. I'm sorry for the guy that was trying to take a picture of that. I'll post it online, I promise. Alex Ianu is a great reverse engineer. He started a blog series called Secrets to the Application Compatibility Database, but didn't finish it. He stopped halfway through, which is a shame because he never got to the really good stuff. And then I found these guys. They blogged about something a while back. And I wish I'd found their blog a lot sooner, but I didn't. Mark Baggett was one of the first ones, I think, to talk about this in a security context at DerbyCon. And John Erickson talked about this last year at Black Hat Asia, particularly about the hot patching, the shim engine stuff. Special thanks to my peeps, John, Greg, Wyatt, and Patrick. John for encouraging me, Greg for yelling at me, Wyatt for helping me with Volatility plugin because the documentation's terrible, and Patrick because I made a lot of my own functions to prevent hooking. I made a lot of my own string handling functions, and he said it made him want to stab out his eyes. And that was good insight for me. Other resources about this stuff, I suggest checking out Raymond Chin's blog. And I just wanted to say I apologize. I am sorry. The application compatibility, I'm adding more load to this crap because I know so many people hate it and it's a pain to so many people. I don't think we have time for questions at all. Out in the hall, I can. So I'll talk to you. I'm a little hungry, so I might try to get some food while people are talking to me. But there's my GitHub and there's my Twitter in case you realize I was cool, and there's my email you can email me at. That's it.